With swimming being one of the most prominent sports here at Los Gatos High School, we want to help the coaches and students enhance their skills by understanding the physics behind their techniques. In this sports science episode, we will explore different factors which affect the athlete's performance.
Today, we will focus on the varsity Los Gatos High School swimmer, senior Kaya Long.
Newton's first law states that a body at rest will remain at rest unless it is acted on by an outside force. Also, the law states that a body in motion remains in motion indefinitely along the same straight line. If a swimmer is swimming in a 50-meter-long pool, after the push off the wall, they start their first stroke. They will be moving through the water at a constant velocity.
To calculate Kaya's constant velocity, we are using the equation velocity equals distance divided by time. The distance of the pool is 50 meters, and the time it takes for Kaya to swim the 50 meters is 25.23 seconds. So, we divide 50 meters by 25.23 seconds to obtain Kaya's constant velocity of 1.98 meters per second.
When moving at constant velocity, all the forces are equal. So, the forces acting on the swimmer in the y direction are the force of buoyancy pushing up on the swimmer and the force of earth pushing down on the swimmer. The forces acting in the x direction are the force of friction on the swimmer and the force of thrust on the swimmer. The forces are equal because the swimmer is moving at constant velocity.
Constant acceleration occurs during swimming when Kaya pushes off the wall, and the speed at which she is accelerating from the push-off is constant.
When moving at constant acceleration, all the forces are still equal. However, the forces acting on the swimmer in the y direction are the force of buoyancy pushing up on the swimmer and the force of earth pushing down on the swimmer. The forces acting in the x direction are the force of friction moving against the swimmer and the force of the swimmer's push off the wall.
Mass is how much matter an object takes up and is constant. Weight is the measure of gravity on an object and can change depending on whether the object is subjected to less or more gravity. When Kaya's mass of 58.9 kilograms is multiplied by the force of Earth, negative 9.8 meters per second squared, we can calculate her weight. Friction, which is also known as drag, can affect the rate at which the swimmers move through the water. In swimming, there is negative friction as the water is pushing against the swimmer's body. When the swimmer is in the water, the force of water pushing up on the swimmer, which is also known as buoyancy, helps the swimmer float. The force of earth, which is also known as gravity, pulls the swimmer down and causes the swimmer to sink. The buoyant force is the difference between the force of the water and the force of the earth, which is negative 636.12 newtons. When comparing diving to swimming, we noticed that there were many differences with the ways that the swimmers kept afloat. To tread water during water polo, the egg beater kick is used to keep players afloat and to propel them out of the water.
The egg beater kick allows players to stay above the water by creating water currents that spirals downwards and elevates the players as normal force works back on them. In water polo, you are floating and there is no acceleration acting on the player. This is different than swimming because there is no constant velocity. Water polo is similar to swimming because there is a push and a pull acting on the swimmer in the water.
Stay tuned for the next sports science episode.